Okay, welcome everyone. We are in week 10. So today, in general, this week and the next 2 weeks, in these 3 weeks in a row, we are gonna work on chapter 6. We are gonna learn more SQL to the advanced level. Today, as a first session, we will do a little recap about what we learned in SQL, and also at the same time, we will learn something new as well. But from the next meeting, we are going to go through more details as well. So let's go to the SQL coding for this 3 weeks. So technically, most of the things that we have done so far are more like a simple type of SQL. Hey, but again, we are targeting more complex version, especially when we are gonna deal with the subqueries. We are gonna learn about the functions, some kinds of built-in functions, aggregate functions, which is very helpful and which is very, at the same time, useful. Whenever you need to do most of the stuff, you need to have function. You need to know how you can use the function. And again, according to those functions, we're gonna deal with the group by, having by. So whenever we have like an aggregate function, group by, that type of necessary thing, we will learn about them in very good way. We're gonna know about all of them in details in these 6 sessions in a row that we are gonna have. And then, as I mentioned, we'll go through the subqueries and also the changes statement we will see. And at the end, we'll go through the database view, how we can see different views of the database. That's gonna be in the last week of this chapter. So just very quick recap that we have that we worked on the so far the structured English query language or SQL for our course. That's the language, a standard language for creating a database, and at the same time, that's the standard language for asking questions from the database. Okay. So as I mentioned today, we are gonna do a little recap, and also at the same time, by end of the session, we are gonna learn more stuff about the SQL, and the rest is gonna be in the following days. So one of the things that we know for sure, it's MySQL is not case sensitive, and unless you use like a quotation for the string, for those, definitely you have to be very careful if you need to have the like a capital letter or lower letter. And then the white space definitely is just for cosmetic purpose, so it doesn't matter. This slide, we are gonna see it for the next 5 meetings plus this one at the very first of each meeting. We are going to review it every time to just make sure that we know and we memorize the order very well. This is what we know so far, that for writing the SQL, we need to go through some specific order, okay? So it's always a start with the select. We know it, which we by select, which means we are going to know what attribute, what column we need to have. Right now, we know what is the asterisk. We know if you want to have some specific column, we can use the name of the column in the select statement. And then from, which is the most important one, that from which table, which data set, which sets based on different notation, from which one we are going to go through them. Then we can use the where in order to filter it based on some specific this one. And then that's a group by and having, which we will talk about them more in the next couple of sessions. And at the end, the order. So this is the way that we need to always remember. So we cannot repeat together. It's always a start with the select, and then goes to the from, and then goes to the where, and then if it's needed, group by, and then having, and then order. Okay. So this type of statement that we have here, this is always we need to remember. And we know that for execution always goes to the from, then the rest of the process is gonna be. And select is gonna be the last one before the order one for sure. So for this chapter, we are gonna work with the Red Cat 2 from now on. throughout chapter 2 and 3 and 4, we work on the REDCat 1. So REDCat 2, it has more detailed table. So technically it's an extension of the REDCat 1. We can see that we have right now multiple extra table, inventory items, item size, I don't know, product, I purchase items, employee, salary employee, wage employee. That's the type of different tables that we are going to deal with. Okay, so the number of tables right now it's more, and then we can definitely write better SQL coding in order to ask questions, in order to create some queries. Okay, so some of the questions, some of the things we are going to see again, definitely you know all of them. So we will go through them and then something new, and then for the couple of next session, every session we will go through the new things. So we, at this point, we all know exactly what this code telling us. So it's just telling us, hey, go through the customer table, and wherever the state is New Mexico, show me the first name and the last, right? Nothing crazy after these 10 weeks in this course. We just know very easily what does this syntax giving us. So we again, just very quick review. Asterisk, which means all of the attributes, all of the columns you want to have. And if you want to remove the duplication, for sure we should go through the distinct. One of the things that we will learn in the next couple of weeks, it's about the different type of joining. From the right join, left join, those things that we are gonna learn. That one, I would say it's more also important because the way that you can merge, you can join two tables and ask your queries, it matters. Sometimes you need to go to the right join, left join. You will see. Those are the good details that it's good to learn. So again, this session plus the next 5 sessions, in total 6 sessions. If you don't want to get bored in class, it's your time to definitely have these windows ready always and start coding. Otherwise, again, you're going to first get bored and probably you're just not going to learn well. So now you are into class, you spend time to be here. So let's just take the full advantage of it, okay? So today we are going to go through different examples, one by one. And for each one, we go and do the coding for it. We start with a very simple one, and then it's going to get better and better, okay? Cool. Any question? All good? So the first example, list about the customers from Canada. So all data about customers from Canada. So what should we do? We're not gonna run the first couple of them in the SQL. So what should we do? You tell me. So the answers. Okay, for sure you all know the answer. So exactly, select all the data for the customers because they mention a specific column from the customer table where the country is Canada. Okay, so based on the again this table, we know that for the customer there is a country option, country attribute, so we can definitely guess which. So which customers first and last name live in New Mexico? Just simple, easy. Select first name, last name from customer table when state is New Mexico. Nothing new, correct? Good. Which cities in New Mexico do we have customers? Oh, we can go for it. So we all know that again, customers, there is a city attribute for it. Okay. So which cities New Mexico we have customers? So select what attribute you want to see. City from customer table where date is new mix. And we might have some duplication, so it's good to have distinct as well. Okay, so nice. Select distinct city from customer where the state is new mix. So this one, the first thing that is new for us. Give an alphabetical, which means you need to sort it, list of the sandals by product name and the total price for 7 pairs. So we know that how to ask for the list price. Go to the sale and check the list price. But we would like to know the 7 price, the price of the 7 pairs. So which means the price, whatever it is, times 7. Okay, but how we can show it in SQL? If you download the PowerPoint, for sure your answer is there, but try to think it if you haven't checked it. How we can do it? And if you remember, I always mention that SQL, it's like a simple language. I mean, the way that exactly you speak English, you can easily just translate it to the SQL. So in that case, first give the list of the sandals by product name. So which means we need to have the product name in the select statement, right? So select a statement by product name, and then the total price for 7 pairs. Okay, so right now, if we go to the table for the product, we have the list price in the product table, right? So we have the product table and we have the list price. So how we can have the 7 times price in the equal? What do you think? The point is, again, we have to have select product name and also the list price as well. Okay, but how we can have the price for 7 pairs? What do you think? Any idea? Even if you check from the PowerPoint, tell me. That's fine. Just easy, exactly. Multiply by 7. 7 times list price. Okay, so that's the easiest way to do it. So let me so for answer, let me go through the so far select product name and the 7 times list price. Technically, we can always do whatever plus, minus, dividing times with the all related column. If there's a number in that column, we can multiply it by whatever we want. We can add it. For example, we have a sale price in one column. We have tax price in one column. We can also do the summation of these 2 columns by just typing sale price plus tax. So we can do all of them in SAS, in SQL. But this is a specific one. What does this one give us for us? I mean, what does this one do in the code? What do you think? He names it price for 7 pairs there. Yeah, because you answer. So do you think what's gonna happen? The select statement, as we always mention, showing us what? Showing us columns, right? Right. Right now we know that we are going to have product name. We are going to have list price, which is times by 7. Okay. So this one that we put it in the quotation, what this one is gonna be in our report. Yes. We might guess, okay, this is probably gonna be a new column, which is gonna be the price for 7 pairs. Okay. So this is gonna be a new column. And what's gonna be in that column, in the whole column? Exactly. It's gonna be exactly the same. So right now we're going to have product name, list for 7 pair as a column, and also under the column the same text, and also the column that's times by 7 from product table where category is sandals, grow order by product name. That's the one. So again, Redcat to MySQL, and make sure to run it on your site, please. So right now we can see the product name is whatever, and we have a new column, price for 7 pair, and 7 times list price. Okay. So right now, if I, for example, add the list price here and run it, we can just see 30 times 7, 210. Okay. But I don't like this column name. I don't like this one. So what can I do in order to get rid of these and having better labeling for it? You suggest me. Any idea? Remember alias. What was the alias when you were doing the SQL? Yeah, what was the alias? For example, customer, we would say C or whatever. So we are naming it with some specific shortening. The same, we can do it here. Okay. So right now, price for 7 pairs, we can just say total price. Okay. And then run it. So right now we can see there is a total price here showing. Also, we can also have as total price. It doesn't matter. We can have it and we cannot have it. It's okay. But whatever we have is gonna be as a label for that specific column. Okay. What's gonna happen to this one? Does it work? Does it work? Total underline price or the underscore price? I suggest total price. Do you think it's gonna work or it's not gonna work? It's not gonna work because again, it should be just one set of characters. So by underscore, we are kind of connecting those. In this case, it's gonna be, we can have just a total alone, but then we have something extra, which there is a space between this. Technically, it would be a something that it should be column, or it should be just one part of those like areas. That's why we can just have it in this version. What about this 7 times list price? What I can do with this one in order to not having 7 times list price? Can I do the same? Yeah, yeah, why not? The same, that's exactly the same. So for this one, we can, again, we are just naming it. Total price, just let's put 7 total. And right now, we can see we will have exactly that one here. We can also still use the as well, okay? But we can also just ignore it. So technically, whatever attributes name we have, we always can rename it like alias, okay? We can say, okay, let's just say you're creating some new label for it. These new labels, just by adding whatever you want after that attribute. If you want for just more like a clear code, maybe it's good to have this as well. Otherwise, it's not necessary and it's not needed. Okay. So technically, right now we are selecting the product name. We are creating some new column in order to just have more informative data sets. So right now, for example, this Saga Sandal price for 7 pair is $210. Okay, so that's the one a way to show different name for each color, right? So the second one that after from we will always learn and we have to check is the where clauses. So by where, which means we are applying some specific condition where, for example, the state that we are selling item is in New Mexico, where the amount of price for this one, this specific shoes is over $100, where the customer that lives, for example, in a specific city in the specific states. So technically, we are applying different condition by where. Okay, you remember that, for example, we had this one greater than equal, less than equal. If the price is greater than 100, I don't know if the price is greater than 50, less than 100. You remember it. For example, if we wanted to have list price is greater than 50 and also less than 100, we had to write list price twice. For each of them, we had to write it, okay? But now we have the new function, which we call it between. For example, exactly when the list price between 50 and 100. That's the one. When we go through the example, you will see. Or the another one that we will learn today is the in operator. By in, for example, I ask you, give me a list of the customers that we sold this specific type of shoes, which they are living in the New Mexico, California, New York, and some more states. For those, we had to go and said, okay, where a state is New Mexico, where, not where again, where a state New Mexico, the state is New York, state is whatever, okay? But here we can define a list and we would say where state in parentheses the name of the states, okay? So that's a one way. So instead of, again, multiplying multi times, typing state is this, state is this, state is this, which probably causes to have some error, typo, whatever in the text, we can just easily say where a state in parentheses California in a quotation. I don't know, New Mexico in quotation, New York in quotation, and we should definitely separate them with comma. But that's also in one of the things. And the other things that we can use in the where is the like function. Like function is really important. Whenever you want to have some output based on some specific pattern. For example, you want to say if in the type of shoes, for example, if there is a something like HITOP. If there is some pattern in the data sets, just show it to me. Or if there are some names, for example, in the customer name that start with the MI. Okay, I don't know, Michael, Michelle, whatever. So that's the type of thing that we can use it with like function. That's all new things that we are learning, and we will see in the example there. Okay, and also the null. For example, I want to see again the shoes that we are selling to the state. That's the state is not clear for us. The state is null for us. We don't have info for that. Okay, so that's also another way that we can use, and also and or not, that we so far used it a lot, and they're gonna use it again. Okay, so this 8 example, just make sure again, do the coding on your side with me, because this is the only way that you can definitely learn better. So which product have a list price over 20? What should we do? Select asterisk from probably product table where the list price is greater than 20. Nothing big deal. It says which products have a list price over 20. It doesn't ask me exactly, for example, product category or product name. It's asking some more general. Okay, so you can just easily have select asking from product table where the list price is greater than equal 20, and we know that for greater than equal, that's the way we write it. Less than equal, this is the way. So make sure to exactly put the equal in the right position. Show sneakers and boots not costing over 50. Do it, please. Do it on your side. Show sneakers and boots not costing over $50. It's telling you using the comparison operators, I mean greater than equal. So you tell me. So select, again, it doesn't ask us a specific thing. Ask from the which table, you know, from the product table. Okay. So where the category of those should be sneakers or category boots. So we technically can't use and, we know that, because the shoes in one moment is sneakers or is boot. We cannot have it. Yeah, we can use the P, and since we are just dealing with one table, it's unnecessary to just have a P dot, because this is exactly what we are dealing. We are just dealing with one table. And the last condition, it says and not costing over 50. So we might say and the list price is less than 50, or and not list price greater than 50. So here, this one is dead. It doesn't work. Yeah, you can say, yeah, less than equal 50. I mean less than 50, or not greater than 50. So that would be the case for it. So let me. So technically, again, select asterisk from product table where the category is sneakers and category is boots, or category is boots, and not list price greater than D. Or you can see all the list price is less than 50, or just and list price is less than 50, right? The same output for sure. List sales where the total of tax and shipping is over 50. Okay, so in that case, we have to first work with the sale table. The sale table has the tax and shipping and also the all the information, right? The question mentioned that the tax and shipping is over 60. What do we do? Mm-hmm. Sale table. Mm-hmm. Okay. Less than 60, exactly. As we mentioned that you can easily just add two columns that have a number on it to each other, minimize them, or I mean, just do the subtraction, everything. You can do all of the things with the different uh, attributes. So simple, select asterisk from the, let me, so now we can see these are the items that we have. So tax, shipping, tax, shipping. So maybe it doesn't make sense for me. So I would prefer to have so right now we have exactly all the columns plus the tax and shipping. Okay, so we can say, for example, this one has total cost, right? So right now we have exactly all the necessary column that we would like to. So tax, shipping, plus each other is $83, which is over $60, right? List products in a category appearing alphabetically, starting with the letter of C or later letter, D, E, F, G, and so on. So what should we do for this one? And think simple. Don't think it like a complicated example. What should we do? We want to have the list of the products that is starting from C and then the rest of the alphabet, C, D, E, F, G, H, I. So what should we do? So we have to select all the columns from the product table. And now we have a condition. The condition we started with where. And we want to see those that the category started with C and the letter words, later words. So less than C. Less than C is gonna be AB. So technically greater than equals C. Okay, so technically it's showing us exactly. So as you see, and we have to definitely put it in the quotation. So showing us all the asterisks from product table where the category started with C. So right now we have sandals, which is after C for sure, and the rest. Okay. So that's also another way to deal with the characters based on the condition that we would like to have. So list products costing between $20 and $50 inclusive using the between function. So for the previous version, we had list price greater than equal 20 and the list price less than equal 50. Okay. For this one, it's easy. So we used to know this version. Now it's easy. Select asterisk from product table where the list price is between 20 and 50. So this is exactly that we can write it. Select asterisk from the product table where the list price is between 20 and the 50. Okay. So, and as we know, always matters for us to have the code as short as possible and more efficient. So instead of having list price twice and write all of them, you can just easily say between 20 and 50. Now it's going to give us all the values. List records for sneakers, sandals, heels, and boots. So what is the normal version that we can do for this one? We want to see all the information from the product table, which the category is sneakers, or category is sandals, or category is equal to heels, or category equal to boots. And we learned it with the in function, you can have a list of all of these and say their category in parentheses, all the names. Okay. So right now, this is exactly the way that we can do it. And for sure, it's much easier for us. So this is the previous version that we learned. And that's the current version that you can see how the code is shorter, faster, and the chance of having error getting less. So we're category in sneakers, sandals, and heels and boots. And just the only thing that we need to pay attention, put them definitely in the quotation, and also having comma to separate each category. And it can be applicable to whatever, it doesn't matter. So find all products with some form of high top, it's a text, in their name. So definitely you don't know, you have no idea about it. But I want you first understand what does it mean for using this like function. So again, like function, which means you are looking for some specific pattern in some text. Okay, you would say like, for example, if it start first letter with A and the third letter with C, and I don't care about the rest. Based on your need, it doesn't matter. Okay, so in that one, we can just say, okay, select asterisk from product table where the product name like something. Okay, so this is the way that we show it. Okay, but what does it mean by this percentile and also the underline underscore that we can use? We call these as a wildcard. Okay, so what does it mean? Whenever we have the percentile, it means it could be one character, it could be two characters, it could be multiple characters. Okay, in this one, whenever we start with the percentile high, percentile h, it means I am looking for some words that start with whatever. It doesn't matter how many characters it has, but they should end to h. Okay, whatever, they should end to h. And again, when this is between the I and T, here we can see this is between the I and T. In that case, it means whatever number of characters that appears between the I and T. So I go to the text, SQL goes to the text, and it sees I. Select the I, and then check whatever it has after. And when it reaches T, it's gonna consider it in the outcome. Okay? And after P, what does it mean by after P? The same explanation. Whatever number of characters after P. Okay? So it could, again, start with P and finish with whatever number of characters. So for this specific one, which means it goes to whatever characters that first see the H, and then for sure I, and then whatever number of characters, and then goes to the TOP exactly in a row, and then whatever characters after. So when I run it, you will see. So one more time, this percent is the wildcard that matches any sequence of character, including empty sequence for sure. And whenever we use underscore instead of percentile, which means just one character. Okay, so if I had hi underscore top, the outcome that I'm gonna receive is gonna be whatever that between the I and T is only one character. Okay, when I run it, you will have a better understanding about it. So let's first the first one. So now it makes more sense for us. Just see here. As I mentioned, whatever number of characters that goes to the H. Here we can see that Rolodex space H. So this one, it's the first percentile. Okay, whatever number of characters. Then HI, which we have HI here. We have TOP here as well. Okay. And whatever number of characters between this I and T as well. So right now we can see HI, GH are those characters that would be considered as a percentile. And then end with P and whatever number of characters after. Yes. Yeah. So exactly, whenever we have after or before some specific letter, like here, before the H or after the P. It could be whatever sentences that have whatever character before H and also after P. When I change this one, it's gonna make more sense to you. So right now, if I took this percentage, what's gonna happen? Nothing is gonna come. We don't know. Maybe there are something, maybe. But the point is, we are gonna have some product name that end with top. That's it, period. If there are something here that's end with top, we are gonna have it. Let's try it. We have Capri high top. You see, now makes sense. What does this percentile do for us? So right now it's done. We don't have anything anymore after. Okay. And let's go change this one. What's going to happen if I remove this one? We will have some wording that is whatever, and then there should be definitely HITOP, which technically this one doesn't have any meaning. So we are assuming we are not going to have any outcome. Let's run it. And yeah, there is no wording that has HIP high top exactly in the middle. That's why it doesn't make sense. And what's going to happen to this one? Yes, please. The point is, we saw this version. So let me just run it. So this HI top, here we can see HIGH top. Okay. And there might be a possibility to have some wording that has this HI and top without any GH in the between. Okay. And again, this is just example. Maybe it doesn't make sense that much. Okay. So right now, what's going to happen to this one as we are discussing? It's just going to start with HI, whatever, TOP, whatever. So let's see if we have them. We have them. You see, high profile, high top. The reason we have this one, because between this Y and this T, there is a word, there is a product name that has OFILEHIGH. That's why we can see high profile, high top sneaker or high top sneaker. The reason we have this one, again, this is the example that you mentioned. Why don't you have just have a high HIGH? But right now we can see there is a one HI top sneaker. Okay. So what's gonna happen to this one? We have percentile. You tell me. It could be space or one and only one whatever characters. Okay, so let's run it. So we can see, yes, we have it. Vital, high top athletic sneakers, high top sneakers. Between this I and this top, there is only two product name, and that character is a white space. It's not a wording. And we said that white space also count. So do you think we would have any answer for this one? HI underscore top percentile. Do we think we would have any answer for this one? Yes, we will just have the high top sneakers because that's the only one. Start with H, and between I and TOP is the one character, which is the space, and this one. And do we think we are going to have anything for this outcome? High underscore top? No, because there is no product name that exactly match with the high. Just only one character, whatever, and top. Nice. So that's how these like operators work. List manufacturer for which the state hasn't been entered. So when we say the state hasn't been entered, which means the state should be empty, should have null values. Okay. So in that case, we can say select asterisk. Let me just stop here and select asterisk from manufacturer where a state is null, right? So we are expecting to see a list of customers that the state column doesn't have any data. When we run it, there is no, okay? Because this one showing us whatever state we have, there is a value for it. And here we can see that the not and null can be combined with is not null. So in that case, we can say where the state is not null. So it's gonna give us the normal outcome that we can see the state column have that. Good? Good? Any questions so far? So let's go to the chapter 6, 6.2, the SQL statement. Again, whatever we discussed, all the details are here. And we are going to the assignment 6.1, and we'll go through the first couple of them. Every session, we will also try to cover some part of the assignments as well in class, okay? So for this specific table, which is again the REDCAT 2, the first question. Give the date and the sum of tax and shipping, okay? So give me the date, one column, sum of the tax and shipping. We know that tax plus shipping is going to be the sum, but maybe we can use the sum function. For each sale from December 20 through December 25th of the 2015, and says between, name the calculated column, sum. What does it mean by name the calculated column? As sum, okay? So again, due to the anomaly within the MySQL for numeric fields, sometimes calculated results have 14 decimal places. And in exact amounts, to ensure your answer is correct, use the round function to 2 decimal places. We will work on the function in the following sessions, but right now, for now, we are just getting exposed with one function, which we call it round function. And round function tax shipping, tax plus shipping, comma 2, which means whatever the value of tax plus shipping has, the outcome, we should round it to 2 decimal points, right? This 2 is the decimal point. So it's easy. We can say, okay, select sale date. We have all the information here. For the sale, we have the sale date here. Tax and shipping is also here, okay? So we would say, select sale date. That's one of the column I want to have. And then it's exactly giving us the answer. If we didn't know this one, we would go with this version, right? Tax plus shipping as sum, right? But because it says it might be a little too long for the outcome, so you can just use like a function here. We will see we have a lot of functions, built-in function, aggregate function. When we use the aggregate function, that would be totally different things. That's the time that we should go with the group by. We will learn. Okay, we are just going step by step. As sum from the sale table, it's saying us to use the between function. So where sale date is between these two dates, December 20 to December 25. So when we run the test, we can see, okay, this is the summation. The code makes sense? Easy, huh? Nothing challenging. Just the only thing that we need to learn is this round function. List the data in the salaried employee table. Okay, this is a salaried employee table about the salaried employees earning between 40,000 to 50,000, right? So select asterisk because you're selecting all the columns. From the salary employee, that's the table name because it says the salary, not the weight employee. And where the salary is between 40,000 and 50,000. If it was a couple of sessions ago, we had to say where salary greater than equal 40,000 and salary less than equal 50,000. But right now, with just this between, we can just make the code shorter and easier to write. Right? Good? Sorry? How many results does it have? Let's check it. Yes, just employee ID 35, employee 45, employee 61. Good. Give customer IDs and cities. So technically it's telling us give the customer ID, give city. This is the two attributes that we have to do. For customers who are located in Chicago, in St. Louis, in Baltimore, and in New York. So again, if it was before, we would say where city equal to Chicago, or city equal to St. Louis, or city equal to Baltimore, or city equal to New York. But right now, easy. Where city in parentheses, the name of the city. That's it. Much, much easier and shorter. And the last one. Give the sale date for sales where sale tax was charged and the total tax and shipping is less than $15. Use the not operation, show all sales data. One more time. Give the sales data, which means asterisk everything. For sales where sales tax was charged and the total of tax and shipping is less than 15. So when it's asking us where the sales tax was charged, it means we should not look for those columns that the tax are 0, because it says where the tax is charged. So in that case, we can say, okay, select asterisk from the sale table where not tax equal to 0. So technically it's going to say, okay, it's going to check whenever the tax is 0, it's not going to consider it. It says not tax equal to 0. And tax plus shipping is less than $15. That's a two condition. First, it shouldn't be 0. It could be anything. And second, the second condition, tax plus shipping should be less than 15. Make sense? Yes? Any question? Yes. Not null. What is the null? We mentioned that when we have the null, which means there is no data. Okay. For this one, if you use null, technically you are also considering those tax column that has a 0 value. When we are saying null, which means there is no data for it. If you say the sale, the tax, not null, which means, okay, I am looking for whatever number except null. 0 is a number and is not null. So technically you would have that, right? But here it says again, where not tax equal to 0, In that case, exactly, you will have those that definitely tax first is not null, and also the value is greater than 0. Other question? Good. So again, for the rest of the sessions, always make sure to just, since you are participating in class and I appreciate it, make sure to just do the coding at the same time with me. Definitely making the class more like interactive, and then you will definitely learn better by typing rather than just watching and just guessing something. Okay, cool. No question. See you on Wednesday. Okay, welcome everyone. We are in week 10, session 2. So today we are going to continue working on chapter 6, which is related to the advanced SQL. Okay, so last session we worked on what we have learned so far, but we learned something new, how to, for example, uh, deal with some specific function, like, for example, in function, like function, or different type of uh, operators, like a between, those things that we learned on Monday meeting. But today we are gonna work on chapter 6, the part that's related to the join function. But as you remember, I mentioned that from now on, each session, we are gonna see this slide. So we will have to always memorize, practice, to just know what are the orders. So we always start with the select, then we will have to write something with from that we need to know, okay, from which table we are gonna have the results, and then the where according to the condition that we have, according to the specific, for example, requirement for the example or assignments that we have. And then the group by, having by, which we will work on them next week and also the next 2 weeks. And the final is order by. But we know that definitely the execution order is always start with from, then where, then group by, then have by, and at the end go to the select and the order by. So again, each session we are going to review this. But join function. One of you tell me what was the join function? Why we are using join function? What was the join function? To two tables. And what type of condition these two tables should have in order to run the join function? They have to share a key, which means the primary key of one of them should be a foreign key in another one. So technically, the only way that we can connect two tables is through the common key, which is the primary key of one, which is the foreign key in another one. So that's the way that we always use the join. And the reason for is, for example, we have like a sale table. We have also customer table. So here we have, for example, sale ID, customer ID. Here we have customer ID. So these two are the common key between these two tables. And the point is, whenever you want to ask some questions based on the sale table, but at the same time, you want to know, for example, this sale is related to which customer and what are the conditions, what are the attributes for that customers, some specific extra information. That's the place that we use the join function by joining this table to this table through this common key, which is the customer ID. Okay, so that's what we learned so far. Okay, today we are going to learn that we have multiple join function. The one that so far we learned, we call it as an inner join. That's a default version that we so far we learned. Okay, so we call it as an inner one. We will see the difference between the inner and the rest of it. The other one is we call them as a left outer, right outer, which we will see why we are writing here rarely used, and the full outer and Cartesian. So that's different type of join function we have, okay? But let's start with the inner join. The inner join, the one that we already have it, okay? So let's imagine this is the let's say sale table. Let's see. This is the customer table. Okay, this is the sale table. So the left circle is the customer table. The right one is the sale table. Okay, we call this area A, we call this area B, we call this common area C. Okay, so whenever we say that, okay, which customer purchased which items, okay? So whenever we are dealing with the customers that have made some purchases, okay? So technically we are just talking in this common area, the C part, right? For example, uh, the customer ID 1 is for Hussein Mohit, and he purchased sale ID 12 for customer ID 1. So we know that Hussein Mohit has the sale ID 12. That's the one interaction that happened, one transaction that happened. So technically, this one, the Hussein Mohit with the customer with the sale ID 12, is in the C area. That's a common area between these two tables. Okay, you all agree with this one? Does it make sense what I'm saying? Does it make sense? So for this example, the instructor table, the section table. Okay, so between these two tables, we will start with the professor ID. Professor ID 1. Do we have any equivalent value in the section B, in the table B? Do we have any for professor ID 1? We have professor ID 1 is related to the section ID 2 for the class CSS 614, right? So we will have it here. That's the name of the instructor is Anderson, right? For the prof ID 2, do we have any value for it? Yes? Yes or no? Yes. Professor ID 2, the section related is section ID 1, and the room is CS 615, and the instructor name, last name is Bob. So the second row is the common one. And for Professor ID 3, do we have any over there? No. It's like, for example, customer 1, customer 2, that there is no sale reported for that customer. So we are not going to have it in the join function. Okay, it's not going to be in this C area. Okay, so that one, we are not going to have it in the final table. The last one, Professor ID 4, we have it. So technically, the inner join, the one that we already learned, the one that we already mentioned as a join, but technically that's the inner join. It's just give us the common area between the instructor table and the section table, between the customer table and the sale table. Okay, this is so far what we have learned for the join function. Now we are just seeing a different way. Any question for the join function, the inner one? No. Look, yes. What is what? It's exactly the similar join that we have so far. We just started. We mentioned that we have different join function before you came. Inner join, left outer, right outer, full outer, and Cartesian. The one that we learned so far, hey, the one that we learned so far, the join, the normal join that we learned, technically is the inner one. That's a default version. Okay. So nothing new. We just mentioned that technically the inner join, the one that we learned so far, is the C area, the common area between the two tables, the common data between the two tables, nothing new. But let's go for the left outer join. So what does it mean by left outer join? First of all, the coding is different. In this one, we always start with, for example, select asterisk from table A, join table B on the common key, right? That's what we learned so far. For this one, that's the way we write it. From table A, this time left join table B. When we are saying left, it means the first table is going to be the left one, the second table is going to be the right one. So in this case, table A is the left, table B is the right table. Technically, we are going from left table to the right table, from table A to the table B, from the first table to the second table. That's the left function, okay? But what does it mean by left? In just one sentences, it means for the normal one, we just consider C. Right now in the left, we also consider this area in the A. So technically, A plus C is gonna be the answer for us. What does it mean? It means in this example that we have right now customer ID 1, Hossein Mohit, purchased sale ID 12, sale ID 12, and the customer ID is 1. So Hossein Mohit has the sale ID 12. What's your initial? DH purchased, for example, sale ID 14. So far, technically, in the outcome, I should have these two. What's your initial? IC. So we have another customer, which is IC, but IC haven't purchased anything. Okay? When we are doing the left inner join, we will also consider IC that there is no purchase from her. Okay? So technically, we are considering those that are common between these two tables and the one that, for example, in this example, haven't purchased. The example we have here, let's see. Professor ID 1. Do we have a value, equivalent value in the section, in the table B? Do we have Professor ID 1? Yes, we have it. For Anderson, for the class CS 614, the section ID 2, the first round. Professor ID 2, yes, there is. Through CS 615, section ID 1, the second row. Professor ID 3, do we have any over there? No, but since it is the left join from the instructor table to the section table, we will still consider to the report. So technically, McDonald, the professor ID 3, there is no section ID and room for this professor, but we will still consider it. Okay? And then the last one, note exactly there is a value over there, so we will have it. But as you see, we don't have any report for professor ID 12 because this is the left join. We are going from the left table to the right table through the professor ID, which is the primary key. Example, for example, like this example that we have the customer and the sale table, they will ask you, hey, go and tell me, for example, which of the customer list that I already have. In the November of the 2015, okay, purchased, for example, item A, item B, or whatever, and which of them have not purchased any items. So in that case, that's the only way that I can also cover this area. These are the customers that have not purchased any. These are the customers that purchased something. Okay? So technically, by left join, what we are doing is exactly considering the common key, common data between the two tables, and those that there is no equivalent value in the other table based on the different scenario that we have. So that's the left outer join. Okay. When we go through the example, it's going to make more sense for you. The right one, obviously, exactly, we are going to have this side plus this side. So when we say, for example, from table A, right join table B, which means we will go from this table to this table. Okay? And we all agree that this one is equal to B left join A. Right? That's why we said here that the right outer, we don't use it that much because you can just reverse the table and change it from the right to the left. Okay? So it doesn't matter if I go from B to A. So technically, I will have just this area. But if I, for example, reverse the table and go from the left to right, still I am having the same data. Okay? So that's the difference between the left and outer, left and right. Based on the scenario, based on the questions, based on the real case that you are dealing, you will understand which one you need to use, the left one or the right one, or do you even at the end need to have any left or right, or just go with the normal inner joint, the one that we already learned before today's session. So the third one in the outer version is the full outer. So technically, we will have all the dates A, B, C all together. Okay, but how? Let's see this example. In this example, for the professor ID one, there is a value over there, which is the rule CS614, and then I'm just putting here to record my voice better. So Professor Divan, rule 614, 614 is gonna be for the Anderson, we have it. Professor 2, the same, we have it here. Professor 3, there is no value over there, okay? So we will have 3 maximum no. This is like exactly from the left one that we saw. And then for Professor 4, north, we will have 4 north, C 615, and also section before. And then over there, we will see that the 6 CS621 for the section ID3, which is this one, since the primary is professor ID, there is no equivalent value in this table. That's why we keep this one as the null. So for this one, it's looked like the left join. For this one, it's look like a right join. Okay, so that's the difference. That's why we will have it. We'll have both, but for one of them, with no section ID, no rule. For the one that we do the right join, there is no professor ID and the last name. Okay, so like the example that we had for the customer and the same table. So technically, for the customer and the sale table, the again left join is gonna be the common area plus those customers that they haven't purchased anything in some specific month, for example. Okay, right join, it's gonna be some sale that there is no data for the customer. That's why we cannot do any match between these two. But at the same time, we will have this common area as well. Again, when we go through the examples, you will understand better how you need to use this type of job. And just let me tell you, you are not gonna use any right join in this course. Always is left join. Okay, because it doesn't make sense. Left one is always easier, make more sense. The last one, Cartesian. So this Cartesian, I myself, I don't know why we should have it, but that's a type of join that technically for any value in the left table, for any of them, for any row, we have exactly three possible scenarios. So this table has three data, this table has three data, so the join function at the end is gonna have 3 times 3, which is a 9 data, which means for Professor ID 1 Anderson, we will have this one once with this data, once with this data, once with this data. So we can see the Professor ID 1 Anderson, there is one here, there is one here, there is one here. Okay, the same for the ball, exactly 3 of them is available, and also for this that's the same. So technically, it's gonna consider all possible scenario regardless of the primary key and regardless of the foreign key. Okay. So in this one, in this case, we just went through two tables and try to find the common data according to the primary key and the foreign key. There is another things that we need to learn how we can merge some tables together based on the rows, based on the data. So for that one, we call it as a union. But before union, let me go through this as so this is like a join syntax that so far we have. So let me check you, let me show you something. In the where is the mouse? Okay. In the very old days of the SQL, so this is on the chapter 6 and it's on 6.4. Okay. So in the old days, let me go. Right now, we know this one. We know that we are selecting some attributes from sale table. We are joining the sale item table on something, join product table on something. This is what we learned, right? That's the join function. In the very old days, in 19 something, so before having the join function, people used the where clause instead of join, and still it works in the SQL. So here you can see that select whatever from the sale table, instead of writing join sale ID table, they would say just from sale, where sale ID from the sale table is equal to sale ID from the sale item table. So just instead of join, we are not going to use it. We always going to use join, but just wanted to show you this one was also an option before, and still you can use it, but join is better. So we always go with the join function. So this part just explaining the previous version that people use the where clause. But what is union? So union, we will have three different type of like a union. We will have union, except, intersect. What does it mean? We have, for example, again, customer table. We have the sale table, some data here, some data here, rows, the data. So whenever we combine all records from this table with this table, based on the common attributes, for sure, which means, for example, if there is two or more than two or whatever common attributes there, based on those, we can have the new table that we can join all data from this with this one, combine all the records together. When you go through the example again, it's going to make more sense. So requires the same fields, same attributes in the combined record sets. The except one is the model that we would say combine all records from the list, but exclude the duplicates from the second list. Okay, and at this last one, intersect, return only records that are in both data sets. So technically just shows the duplicated version. So that's how we write it. Select whatever column from table 1, union, select those columns from table 2. Select whatever column from table 1, except select whatever columns the same exact column from table 2. Or select whatever columns from table 1, intersect with the select column from table 2. Technically, this except, this intersect is can also replace with the union. So again, we'll go through the example and it's gonna make more sense for you. So before going through the example one more time, let's review the join, and this time you help me. So customer sale table, A, B, C, B. Okay, so the normal join, I will ask you, for example, tell me which customer has purchased items in the last November. So we know that. Select, for example, first name, last name, whatever, from the sales table, from the customer table, doesn't matter. Join to the other table on the common keys. For example, customer ID, which is a join between these two. So technically, what I'm going to receive is just the common area, right? The C area. So that's the inner joint, the normal joint that's so called in there. Now left outer joint. That's the target. I would say, okay, I need you to tell me, for example, in last November, which customer purchased these specific items and which customers have not purchased anything in that specific month. So in that case, we are gonna have A plus C area for the left one. The same for the R. Those says that there is no value on the customer table. So again, that's the B plus C. That's the right. What we mentioned that A left B is equal A right B is equal to B left A. A right B technically is equal to the B left A. Does it make sense, this thing? Right? Makes sense? Instead of coming from B to A, still we are going from B to A, but from left to right instead of right to left. Okay? Instead of going from this one to this one, we can just switch, reverse these two tables, and then go from the same to the customer. Okay? And the full version, which is the again having all of them, and the Cartesian, again, regardless of the whatever condition, whatever attributes, whatever primary key, foreign key, whatever data this one has times the other one, that's a possible combination of them. So if this one has three option, three rows, the other one also three times three, 9 records. We will have it in the Cartesian model. And then we learned about the so far the union and accept and intersect, which you can combine the data of tables according to the common attributes, common columns, and just combine all of them with the union, combine all of them, but removing the duplicated with the except one, or just keep the duplicated with the intersect option. Okay? So right now, same as previous session, we'll go through the examples. Okay? So the first one. Before going through the first one, I need to go and have some water. Just thinking about this one, easy. We have. Select all fees from the join product and manufacturer table from manufacturer named Fila. So, and probably it make more sense for us if we also have the table as well. So I think we have the table. Nice. So again, product table to the manufacturer table. So what are the common keys between the product and manufacturer? So product and manufacturer, the common key is manufacturer ID. Okay, so technically we should connect these two tables. And the point is, it's saying us again, join of the product manufacturer table, which the manufacturer named Philo. So technically they want those product that manufacturer, so that's C area with some specific condition. The condition is Philo. Okay, so let me have the code. So red cat 2 for sure. And select asterisk again from product table. We are using alias. Joining manufacturer table on manufacturer ID from the product table, manufacturer ID from the manufacturer table, where manufacturer name is Fila, right? So technically, this is exactly the normal join we have. Am I right? We are exactly having one table like product. This is also manufacturer table. We are exactly in this area, which they are created by Fila, right? That's a normal one, nothing new. List sale ID, sale date, product ID, quantity, sale price, all the things that we need to have in the selected statement, and extended price, which is the quantity times sale price for all sales. Okay, so this one is also nothing crazy. So technically, the table that we have, all of them are in the sale table and the sale item table. These two tables that we have to connect them by sale ID. But since there is a sale ID in both tables, we have to mention which sale ID from which table. Okay, so right now, first one, sale ID from the sale table, sale date, product ID, quantity, sale price, quantity times sale price as extended price. Can we remove this as here? Can we remove this as? Yeah, we can remove this extra. From the sale table, join sale item table on the common key. The common key is sale ID from the sale table on the sale ID from the sale item table. So the only thing that again, if I remove the sale ID here, I mean s dot sale ID, we will see that it says that column sale ID in field list is ambiguous because sale ID are available in two tables and we have to mention from which table we need to have it. Okay, and that's the only way that you can learn coding, again, just by do this type of critical thinking. Just see, okay, if I remove this one, what's going to happen? If I add this one, what's going to happen? Believe me, that's the only way that you can learn, just by watching here, sitting here, watching the table or watching the YouTube video. It doesn't work. You have to go and do yourself. You have to type it. You will learn when you type it. Even by copy and paste doesn't work. Your brain should just get to know it. You might say, okay, I can do it. I can ask ChatGPT or whatever generator to do this. But at the end of the day, you are going to be dependent to that tool. You have to know, you have to have a knowledge, and then that's the time that you can use these generative AI tools in order to increase your performance, in order to enhance your performance. So list employee with the name of their managers. Do it on your site. I'm not gonna show it this one to you soon. List employee with the name of their managers. And from the table, oh, where is my mouse? The employee table, we have employee ID, we have manager ID as well, right? So which means there should be a, what we call this one, recursive relationship. There should be a relationship with itself. Okay, now we have employee ID, we have manager ID. The hint is technically you have to consider employee table twice virtually. One like a E table, which is the employee ID, one like a S table or M table, which is the supervisor table or manager table. They are exactly the same, but you have to name it twice. You have to call it twice. One for the employees, one for the managers. Okay, now do it on your side and tell me what you think. Even though you are dealing with one table, but you have to treat it like it's two different tables for one of them. We should deal with the manager, we should deal with the employee ID. How we can do this? So regardless of whatever in the select, it doesn't matter. First name, last name of the employee, first name, last name of the manager, supervisor, whatever. Okay. We are starting from which table? Employee table. Employee. We name it as a E. We are joining which table? Exact this time again employee, but M or S, manager supervisor. On you tell me. Of which table? Employee ID of the E table. Employee ID. Employee ID on this one. Again, employee ID of the manager table. What else you think? Where is the manager ID? Okay, one more time. We should have one employee ID. We should have one manager ID. But this one from which table? This one from which table? It's that same. Let's say E, M, or M, E. Let's run it. So this select doesn't matter. We are saying that selecting first name from the employee table, name it as an employee first name. selecting last name from employee table, name it as a employee last name, first name from supervisor table or manager table, name it manager first name, and also for this one. So far from temp employee, which we name it E table, joining employee table, we name it S table. The question we had was E or S or S or E. Okay, let's run this one. When we run this one, it's saying us Louis McDougall or whatever technically is reporting to Louis McDougall. Audrey McLeod report to this one. Kylie report to Louis. Zachary report to Louis until Jerry report to Audrey. So technically based on this, I can say that the Louis is the top because reporting itself. And then we have it. Which one is the second one? Audrey. And after Audrey, Kylie. Okay, but let's do it on the other side, which means replace S E. Now we can see all the Louis, it's gonna be on the left side, but did they run it? So technically it doesn't work because it shows the Louis was the highest level right now is reporting to this guy. The point is the normal version, the way that we should deal with this one, we will say from the employee table which manager supervise which employee, okay, from the managerial table. One more time, which manager in the normal employee table supervise which employee in the supervised table or manager table. Third time, which manager in the employee table supervise which employee in the supervised table. Okay, it might be a little confusing, I can understand. Easiest way is always to check double, then it make more sense for you. But that's the logic in this specific example. So technically, you have to do it always reverse. The first thing that came to your mind was, okay, employee from employee table, supervisor or manager from the manager table, but this is not the case. It should be always reverse in this specific recursive relationship, okay? List customer name with the product category, product description of the product each customer purchased. So technically you have to deal with the product table, also the description. Where is the description in this table? Description is also in the product table. So product table, and where is it? Oh, and also the customer table. So technically you should deal with almost three tables. Okay, so technically you should deal with the product table, you should deal with the customer table, and also sale ID table because it's asking us about the purchasing. So if we go to table, the product table that we have here, the customer table, and also the sale item table, how we can do this connection. So based on the question, it's telling us selecting customer name with the product category and product description. First name, last name, category, product name, and description as well. Is that correct description? Okay. From the customer table, we are gonna join, sorry, for table, we have to go. From the customer table, we will go to the sale table. From the sale table, we will go to the sale ID, sale item table. And at the end, with the product ID, we will join to the product table. So from customer table, C, join sale table and the customer ID, then join sale item table through the sale ID, and join the product table through the product ID, which is between the sale item table and the product table. So right now, we will have the first name, last name of the customer, the categories of item that they purchased, plus the product name and the description. Okay? Yes.
What would happen if you schedule just because it's in the swing sale at
Inventory item. Let's go to the table. So inventory item. If you need any of these items, you can consider it. If you want to say, okay, I need the item size. In that case, you should definitely consider this one. You mean beside no, instead of product using inventory table. So in that case, you can't have access to the description because we need to have a description. Always based on the attributes, you should look for which table you are gonna deal. If we, I think here, first name, last name, category, product name. Again, also product name is here, is not here, is here. So since product name is needed, category is needed, description is that we have to deal with this table. But yes, we could go from customer to this, and sale item to inventory item to this one. Yes. And again, this select statement is the same. You just did the extra work. That's it. Nothing is gonna change.
so you don't need that.
Yeah. So technically, you can have one more line here between this one. So from the sale ID, go to the from the sale item, go to the inventory item through the product ID, and from inventory item, go to product table. You can, it doesn't matter. If you go with this one, you can also have two more columns as well here, item size and quantity on hand. But if you don't consider them, technically it's the same. That's the way that I'm always saying, that's how you learn it, exactly like this question. What if I go through this to this instead of this to this? In that case, you can just try to like replicate the code with the different tables and see the results. Yeah. And it makes sense, right? Because again, customer, there's the logic is always the same. From whatever to table to whatever table, if there's a common key, and if it works in that specific example flow, here customer table to sale table through the customer ID works. Then sale table to the sale item table through the sale ID works. Sale item, we went to the product just through the product ID, but right now we can go to this and this to this. It doesn't matter. Based on the attribute we wanted to see is extra job, but it still works. And why it works? Because at the end of the day, whatever table you connect to each other, it's gonna go through the common data, common availability. Yes.
Let's ask for customer name. We just assume it's both last name and first name.
The customer name, because there is no customer name here. We have first name, last name. That's why we are saying, okay, let's have first name and last name.
But like just first name?
It doesn't matter. It doesn't.
Doesn't take place.
Yeah. Oh, based on the question. So, oh, you mean, for example, exam or something. So it's always should be full, both of them, first name, last name, as a because you need to know who is the guy. If it doesn't specify, for example, if they mention again customer name, always put first name, last. If they mention, for example, just last name, just put last. It doesn't matter. Okay. And if this is the exam question, and if you just put the first name, not last name, and if the book reduce some points from you, just let me know. I will give you the points. Because again, to me, it doesn't matter first name and last name. The things that matter is you just learn the whole logic, not a specific column. Okay. So don't worry about these details. Just learn the whole logic. List all customer who did not complete a sale. Do this one. All customer who did not complete sale. That's the customer. That's the sale. Which area we are looking for in this one? A, C, D. Which area we are looking? The customers did not complete a sale. The customers that have not purchased any. Full? If I go with full, what's gonna happen? I'm gonna have A, C, D together, which means I'm gonna have those customers that also have purchased. Okay. Which one we should go? Which one I want to see as a result? A. But how we would just have A? Because we know if we use left one, we are gonna have A plus C. But I want just to see A, which means those that the sale ID is no. Right? So in this case, if I say, okay, from customer table joining the sale table on the whatever column left join. So I will have A plus C. In the final table, I will have the customers that purchased plus the customer that didn't purchase. If the customer didn't purchase, the sale ID for those are no. So just with one extra where sale ID no, I can say I am going to have just the customer that they didn't complete the purchase. Like this. Makes sense now? What does it mean by left join? If you didn't have left join, you couldn't answer it easily for this one. Because whatever join that you are doing is just giving you this area. If you are using the normal join. You should have the left join to have A plus C and filter it one more with the last version, last step, which is the where cell ID is null. Now you will just have this A area. Let me run this one. It makes more sense in that case. Okay. Select first name, last name, cell ID, cell date. That's the between the customer and sale. So the common key is customer ID, right? So right now I would say from customer table C, left join sale table S on which one, which attribute? Customer ID. If I don't have this one, what's gonna happen? I'm going to have those customers that purchased plus those that haven't purchased. If I took this one out, what's gonna happen? What we are gonna have in the report, in the outcome? What we are gonna have in the outcome? Tell me. In the outcome, what type of record I'm going to have? Purchased. Only the one that's purchased, right? Right. But left one, it's going to give me those that purchased plus those that have not purchased. Right? And where the sale ID is null, it's just gonna give me the customer that they haven't purchased anything. This example exactly should tell you how the left join works. What does it mean by left? If you know the left, the right is the same. You are not gonna use the right. Always reverse it and use the left version. Cool? The last example, because I want to go through the assignments as well. So let's just read this one. Use the union query to all customers from a state of Minnesota with a column literal from Minnesota and all other customers with a literal not from Minnesota. So let's go directly and run it. It means select first name, last name, a state as from Minnesota as customer. So we know what this one works, how this one works. It's gonna create one column that all the values are from Minnesota, right? We know that from last session. From customer, where a state is Minnesota. This is one table. Do you agree? This is one table that giving us just the customers from Minnesota. Agree? If I just run it alone, this one, I'm just going to have those that's technically from Minnesota, right? Now, I'm saying it union. Union, which means combined all datas from table E with table B. It doesn't matter if it's duplicated, it doesn't matter anything. So what is the other table? Select first and last name, a state, this time not from Minnesota as a customer state, from the customer where a state, what does it mean? Not equal to Minnesota. So this is also another table. With this union, now we will have a combined table which where the state is not Minnesota, it's gonna say not from Minnesota. Florida, not from Minnesota. Pennsylvania, not from Minnesota. But if it's Minnesota, it's gonna say Minnesota. Bless you. Okay? Cool? Good? So we learned today different type of join function. What does it mean by left one? When does it matter to use the left version? And then we learn about the union, and also for these two, if we use the other one, intercept or the other one. So technically one just add, remove the duplicates. The other one just keep the duplicate. For this example, Technically, there is no duplication because we are categorizing it within two groups. So there is no duplication between these two tables. So let's go very quick through the example, through the assignments, at least the first three. So 6.4, chapter section 6.4, assignment 6.2. Okay. The first one. Who are the customers from Illinois who bought boots costing over $100? Show first name and last name only. So first name and last name, which means just select first name, last name. Since it's just first name, let's use the distinct as well. Customer, Illinois, customer table, Illinois, again shows which part. The boots, so we have to deal with the category, we have to deal with the product table. And also the sale item table is the one that we should definitely consider. So technically from customer to the sale item table, and from sale item table, we can deal to the product table as well. Okay. So from customer table, join sale table, sale table to sale item table, and then product table. So all the common keys are here, where state is Illinois, list price is over 100, and category is boots. So just two customer. What are the names of the product from manufacturers in the Washington state? So you can watch all of them in YouTube later if you want. Select distinct product name from product table. Join manufacturer table. Again, product to manufacturer. Through the manufacturer ID, where state is Washington state. And the last one, list hourly employees, wage employees, first, last name, their hire date, then full name, first name, last name of their manager, rename manager name, call it as a like a manager, first name, manager, last name. So technically from employee table to the wage table. Okay. But the point is, employee should again consider twice because one is for manager, one is for the other one. So from employee table, going to the wage employees through the employee ID, and again, join to the employee table as a manager. And this time, again, we can see it's reversed. Manager ID from the employee table, employee ID from manager table. Reverse. So in that case, we will have these people that Helen, Polly report to Kylie, Sisk, Joseph report to Kylie, all of them report to Kylie, and Kristen report to Zachary, and Jerry report to Zachary. So technically Kylie and Zachary, at least in this case, is the hierarchy in this organization. Good. Any question?